Hey guys, today we're going to talk about something called polar graphs. So we're going to talk about polar graphs, and what we need to know is we have to remember our polar coordinates. Remember polar coordinates. And for the polar coordinates, it was given by r theta. R is the distance, theta was the angle. So r is the distance, theta is the angle. Now in class I'm going to give you a polar graph paper, but for what we're doing here, taking notes, we could just do it on a regular axis. So let's jump right into it. So we're going to talk about polar equations. Now, most of these things you've never seen before. So it's going to be like the first. So, but the first one, it's a circle. Now, a circle is given by r equals a number. So if r equals a number, that's a circle. So for example, if I say r equals, let's say 3. Start off, r equals 3. You go out 3. There's going to be my circle. And what's nice about a circle at r equals 3 is that it's always 3. So no matter what angle I gave, so at 90 degrees, it's 3. At 0 degrees, at 45 degrees, it's 3. It's always 3. So that's going to be a circle. R equals 3. Now, we're going to graph in polar, and we're actually going to use a different mode in our calculator. It's called polar, and we're also going to do what do you call it? The special graph paper with it also. So we're getting there. Next one is called the spiral of Archimedes. Spiral of Archimedes. Now these first 3 that I'm doing together are like I don't want to say not important, but they're more of a can you recognize the picture kind of problem, where the later problems that we're going to go into are where you have to be able to explain, understand what's going on. These first 3 are kind of like, multiple choicey, pick out the answer kind of questions. All right, so spiral of Archimedes, r equals, and r is an angle. So the first one is a number that makes a circle. If r is an angle, it's some kind of a spiral. So now what that's saying is r equals the angle, and we're going to do this in radians, right? So r equals an angle. So at 0, it'll be 0, right? And then as we go around this thing, it's going to go like this. And you see this a lot, like in biology, like a nautilus shell, the spirally snail, that kind of shell-looking thing, and it's called the spiral of Archimedes. All right. Now the last one we're going to talk about for this group is called the lemniscate. Okay, it's a lemniscate, and what this one's going to look like, it's going to look like the infinity symbol. All right, now this is probably the hardest looking formula, but it's not really that bad. So it's r squared equals a squared sine 2 theta, or r squared equals a squared cosine 2 theta. It's always 2 theta. It's always 2 theta. But the value a in the front is going to tell you how long the little like a petal is on this thing. So for instance, let's say if we give you a problem, something like r squared equals 4 cosine 2 theta. So r squared equals 4 cosine 2 theta. Now, if I was actually going to graph this in a calculator, which we will, but we'll do that in class, I would take the square root. Well, the square root of 4 is 2. So that means the little petal is going to go out to 2. Something like this. And it's going to go down like this. And it'll look nicer when we graph it on real graph paper. That one's a little rough. And it's always 2 theta in the back. And if we do a sine one, it's going to be like on a slant. But for this one, that's what it looks like. All right, now let's try the next ones. Now this is the ones where we really have to like kind of look to see what's going on. And so this is going to be called the first one. Well, it's the last one we're doing tonight. It's called a rose. Okay, it's called a rose. Now, and it's just more of a, it looks more like a flower petally kind of thing. Okay, but they call it a rose. And so what this shape is going to be is r equals a cosine n times theta, or r equals a sine n times theta. And n has to be greater than 1. Now, what we're going to do is I'm going to graph a couple of these, and then you're just going to see what the graph looks like, and that's going to we can see what the pieces do, what the a value does, what n does, what does cosine do, or the sine do. So we'll see what all the pieces are. All right. So let's take a look at the first one here. So we'll say y equals 4 cosine 2 theta. All right. So I got y equals 4 cosine 2 theta. Okay. Let me just get a graph here, and here's a graph. Y equals 4 cosine 2 theta. And that's what the graph looks like for y equals 4 cosine 2 theta. Oops, it disappeared. Okay. And I know what it looks like. It looks like this. Oh, it's rough. That was a little rough. Let's check. Let's drag this here. That'll help. Okay. So if we look here, the petal, right, goes 1, 2, 3, it goes out to 4. So that's the petal 4. Well, let's try another one. What if I put y equals negative 5 cosine 2 theta? So that's why we have the same basic shape. So I'm just going to enter negative 5. So y equals negative 5 cosine 2 theta, and hit graph, and let's see what this does. Okay. 1, 2, 3, 4, 5. Same shape, but now it goes out to 5. All right. What if we did sine? Okay, let's try sine now. Y equals, delete that, 4 sine 2 theta. Okay, y equals 4 sine 2 theta. And I'll draw this one too. So y equals 4 sine 2 theta. And take a look at the way it's angled. Looks kind of like a 4-leaf clovery thing. And it goes something like this. Now, if we could measure it, you would see that these petals go out to 4. This number in front, the a value, tells us how big it is. And if you remember, when we graphed the one that had a negative 5, it still went out to 5. So what this a value does, the absolute value of a, is the max r value, or in this case, the length of the petal. It's the length of the petal. So if you see a graph and you something straightforward, if this went out to 3, let's say, right? Then you say, oh, it's something 3, blah blah blah, 3 cosine. Okay, so well, hold on now. We just did cosine side to side, and the sine one is kind of like this, diagonal. Let's do another cosine problem. Let's do a weird one. Y equals 4 cosine. What if we change the theta? Instead of 2 theta, let's make it 3 theta. So the petal should be 4, right? So we know the petal should be 4. But now, take a look. So it's y equals 4 sine 3 theta. Cosine. 4 cosine 3 theta. Let's just fix that. And it looks like that. Okay. So something like this. It goes like this. something. It'd be all the same size petals. Okay, so that's cosine 3 theta. And if we did, let's try the sine problem. Let's do sine now. 4 sine, do sine 3 theta. Let's see what that one does. I have no idea. Let's take a look. Let's take a look. Look at. Okay, it's okay. It looks like this. That's not. I'm not even trying on that one. Hold on here. Hold on. Oh, that's rough. Okay, let's take a look at that again. Okay. I guess a little better. All right. And that's 4 sine 3 theta. So what does the cosine and sine do? Well, cosine is symmetric in the x-axis, and the sine is symmetric in the y-axis. And now, wait a second. Now let's talk about this n. When we did n, 2 theta made 4 petals. 3 theta makes 3 petals. Let's try it again. Well, what if I make, let me put a 4 in here for 4 theta. 4 theta, whoa, 4 theta makes 8 petals. So 4 theta is 8 petals. Let's try 5 theta. And now 5 theta makes 5 petals. 5 theta is 5 petals. So what's going on here? If I did 6 theta, I would tell you this. 6 theta would be 12 petals, but 7 theta would be 7 petals. And what that tells you is this, that n, if it's odd, that's the number of petals. And if n is even, you have double the petals. Double the petals. Or you should say 2n petals. That'd be the fancy way. And that's pretty much it. So when we're looking at this thing, we got a couple of things. Okay, ready? The a value tells you how long or how big the petal is. The n value tells you how many petals. Odd, that's the number. Even, you double it. And cosine and sine tell you if it's symmetric with the x-axis or the y-axis. All right, so that's it. Have a nice night.